July 14, 2018. This video is to show fundamental physics. Physics fundamental by asking a fundamental question. But before we get to the answer, it would make sense. You need to consider the question carefully. So what you have here is, this is just a nail, and this is a magnet here, and with a string connected to it and hold up by this pole, or whether I can hold it up or the magnet hold it up. Either way, it's been held up by a lot of pretty good strength here. So from this point, we asking, is gravity, gravity, the mechanism for gravity, is this a force? I'm lifting this nail here, and of course we got to the magnet quickly. Well, whether using classical gravity, gravitational, or you use general relativity. Well, regular, classical, we fine. We all know. It's a force. Whether you can looking at it from the Newtonian equation, or you talk about general relativity, which is in this case the mechanism. But again, both would say, to the point and say, okay, the cause for the mechanism for this object to go toward Earth is with a force this way, or it's a curve of space and it fall down. But either way, it needs some sort of force for it to move. So in this case, it have to be a force because this here want to go down that way, and what hold up is the upper part here, this nail, and of course by the string, by this magnet, and suspended so therefore it's a tug of war, and so there's a force going this way as gravity going this way, so it's cancel this out. And so now you can subtract the two string endpoint out because they are equal and opposite. That's why you're able to have it balance out. And if I remove this line here, now you're going to be, now you no longer have contact force. And so, well, that's not working well. Well, let's try it again. Now, as you can see, this string now broken, and you can see now the nail is suspended by the magnet here. So now you no longer have standard classical contact force. The question would be, initially, if you can ask a more complex question, it's easier to say, okay, so if force of gravity is always that way, where is the energy source to give such force? But that may be complicated and abstract. Now we're talking about, so let's remove that question, and now we ask about this magnet alone here, this magnet. So at this point, this magnet work from gravity, push the nail that way, magnet energy work pulling up this way. So energy being spent. So when you have a system this energy been spent right here, work been done. That means then you need to have an input. Now, where is the direct energy input to the magnet so that it can continue to spin, to work against gravity? So that is the fundamental question. The magnet cannot be a perpetual energy generating machine, because if we even when you accept E equal to mc squared, they're the mass, but the energy have to come from somewhere. And this magnet continue to spend energy right now, work against gravity to hold up this nail, to suspend this nail right here. And so I think it's sometimes it's the most simplest question. If we use the term, say, is there quantum involved here? Well, this is just a physical big object, macro object. It's the quantum doesn't involve the nail. And again, in this case, you can say, oh, the magnet themselves, the main themselves with quantum effect doesn't matter. We still talk about the energy consumption. Similarly for gravity, is where is the direct energy source input from in order to keep this system the way it is. But that's why we subtract out the gravity, subtract everything. Now you ask the magnet here, this object here, the direct energy source. And if we can say it can apply, let assign this one 1 Newton pull, in this case force here. And now you yet apply that over time. And for skip, multiply it by, or make it, assume let go in a million years or something. I mean, would that able to do that? And now if you put this whole thing in the vacuum chamber so you can take the air out, I mean, you can remove everything. You still have this set up. You still have the energy, take energy from the magnet here to cancel out gravitational that way. And why this question is fundamental and important. Well, it's more than just whether there's a magnetic, whether field involved, whether all these things or gravitational field. We're talking about, again, yet simply energy input in order to consume, to spend on fighting or tug of war against gravity here for this magnet. And so I think over a long time, try to have a question. It's very fundamental but very difficult, because again, that would answer, if you answer this question, where is the energy source, then you would able to answer something more abstract. For example, if you decide to go more abstract, and you go to NASA website or something and looking at the supernova remnants, 0509, that's 67.5. And you can see that remnant doesn't have a center object. And where is the direct energy input from in order to get that super huge object glow for so long and continue to glow? But closer in, I mean, again, in the abstract sense, you're looking at the Spitzer telescope picture of comet Holmes, 17P. When it glow, it break up and it glow, they increase by like 1 million-fold when they were near Jupiter. So where is that energy come from? And what is that energy input? Answer the question, this question, we answer the other two questions, which is less abstract. This is more direct right here. See, you can see movement or this or that. That is take work to keep it in place. And so, but my answer to where the energy comes from, I mean, before we get to there, you have to understand, in this case, the geometry of the energy field of this object, this magnet. And the energy have to conserve. In other words, you have the energy input, and if there energy spent, therefore it have to get the input from somewhere to replace it. Because if you spend at 1 Newton, I mean, I'd say, per second, then over time, I mean, in an hour, that's 3,600 Newton. That's a lot of energy. But where you have account for every single Newton or joule or anything here, you have to account for it. So you have to understand why this object here able to conserve itself. And so that is my perhaps next few video, and also my past video. They'll understand the symmetry of the field, understand a lot about how these the structure of how the energy. Even though we can say field is a concept, no, I mean obviously here field do work. So it's not a concept, it's work in here. So we'll have to agree, or at least have good understanding of what the geometry of this field, and why the geometry ensure the thermodynamic, all these laws. I mean, the energy need to conserve. Thanks for watching.